All right, so I am going to go over a quick question from section 3-4 in the Holt textbook. This is problem 12 in the paper text, so it's probably really similar to the other one. So we're doing problems where you have a little bit more, you kind of think about a proof to use to solve it, but this specific problem says, okay, that was not a very good line. Here's another one. So if you have two parallel lines and it is cut by a transversal here, and this specific problem says you have 3y minus 2x here for this angle. It says this one is 90 degrees and it says this one's 2x. So you have to decide what it's telling you and what you're looking for. So you have to find what the number is for x and y, and so you have to think about how they're related. And so what I would think about first is, how are these two with the letters related? Well, they're opposite. So here's our transversal. They're opposite or alternate, not opposite, alternate interior angles. So they're equal to each other. So their measures are equal. So we do know that. We know 2x is going to have to equal 3y minus 2x. Doesn't get us anywhere because x and y are different letters. You can't combine them and you can't solve that. So then we have to think about, well, we know this one's 90 degrees, so what's this one going to be? Well, they form a line, so they add to 180. If this side takes up 90, this side has to be 90. So let's think about what that tells us. That tells us that 3y minus 2x has to equal 90. Again, you still have two letters in it. But think about substituting this 90 in, oops, for right here, because I'm going too far, because those are equal and one of them equals 90. So then 2x also has to equal 90. All right, so we can divide by 2 and x would be 45 degrees. So we can find the answer for x kind of in a roundabout way, but that's one way to think about this problem. The other thing now is we still need to find y. Well, we can put this in to our formula here for x and find y. So we know that 3y minus 2 times x, which we now know is 45, has to equal 90. So from here we can times the 2 times 45, which would give us 90, and I get 0. Oh no, okay, suddenly I thought I was going to get 0 as my answer. So let's bring this down. We have 3y minus 90 equals 90. Okay, so then we're going to add the 90 over, and in my head I was solving it. I solved it ahead of time and I was messing myself up. These would cancel. So we'll have 3y equals 180. So divide the 180 by 3 and you get 60 for y. Okay, so y has to be 60 degrees, x has to be 45. So let's look at what we did again. So when we look at any type of these problems, which you do have on the next test, and they are part of quite a few different sections similar, you have to think about everything you know. So that's why I just wrote down everything I know. Well, I know these two are equal, so I wrote that down. I know these two equal 180, but we knew half was 90, and we could relate that here. And then we know, well, we could think of this has to equal this one, that 90 degrees. So actually, if they're on the same side, on the inside, they have to equal 180. They add together to be 180. If that one's 90, that one has to be 90. So that was another way you could think of it. There's lots of ways to do these type of problems. Just think write down everything you know, and then use those formulas to find x and y.